A binary system consists of two stars, okay, of equal mass m, okay, orbiting each other in a circular orbit, okay, fine, orbiting each other in a circular orbit, okay, under the influence of gravitational forces, actually, okay. If actually those binary stars orbits, okay, hmm, then it will, I mean, both will go like this actually. I mean, because if they have same masses, okay, m and m, okay, then their center of mass is at the geometric center, okay. So then they usually moves like this. Is that okay? And now you can see here, this r is fixed actually. Am I right? Fine. The distance between them, that is fixed actually. Even if you go for equivalent one body problem, that will also give you one what you call circular motion only. Is that okay? I mean, this is a two body problem. Okay, this is my center of mass. Okay, if they rotate on a circular orbit, so they will rotate about this center of mass. And you can see here in this rotation, distance between them is fixed actually. In the equivalent one body problem, this r only playing the role. Am I right? From O prime, R is the what you call, you take one O prime, okay? There is mu at a distance R from O prime, isn't it? So can I say like this? Now you see this one, how I handled the problem. I mean, you can do it in many ways actually, okay? Fine. Under the influence of gravitational forces, okay? The period of the orbit is tau, okay? Fine. Now what I do is, I'll go to equivalent one body problem, okay? So then can I write that speed? If suppose this mu is going around the circle, okay? What is the speed actually? Speed can I write as 2 pi r. R is the radius of the circle. Okay, so can I say like this? R naught here, R naught here. Okay, 2 pi r naught divided by tau time period. Okay, fine. I mean, because he mentioned the period of that circular orbit, I just defined how that period is defined. Okay, that is speed in that circular orbit. So 2 pi r naught is the radius of the circular orbit. Okay, divided by tau. Okay, so then one more thing he said, under gravitational force, that means f of r naught is equal to what is this one, minus m v square by r naught. I mean, because circular orbit again, okay? I can always write this one, but be careful. Here you write mu here. Because I'm taking equivalent 1D problem, okay? I feel that is more comfortable for me, okay? So that's why can I write like this, f of r naught, okay? In this equivalent 1D problem, okay? I mean, okay, if these are doing circular motion, I mean, about their center of mass, then distance between them is fixed. In equivalent 1D problem, that r naught is also fixed. Then mu is also doing one circular motion. But what is mu here? It's actually m by 2. Can you guess? M1, M2, m into m divided by m plus m. That is m by 2. Anyway, I don't consider this, okay? I mean, I don't need that one. That will get cancelled. I'll show that one, okay? Fine. You can see in the option, everything is in terms of this time period tau actually. Okay, fine. So see this. So then what is that f of r naught? Then can I write it as minus k by r square? Minus k by r square, r naught square again. Okay, that's equal to minus mu v square divided by r naught. Okay, fine. I'm just collecting whatever he gave. Okay, fine. So this negative sign will get cancelled. Okay, where k is equal to g m into m. Am I right? But I will keep k as k. Okay, fine. Since I'm seeing the equivalent 1D problem, okay, I'm taking mu here. Are you understanding my point? Okay, not m or something. Okay, I'm taking mu here because I mean, otherwise it's a two body problem actually. I mean, it's very easy to apply the equations for equivalent one body problem. Is that okay? Are you getting this logic? Okay, k g m into m. But I don't need this one. I'll keep that one as k. But be careful. Whatever I'm thinking equivalent one body problem because I don't have to worry about two bodies in this equivalent one body problem. Okay. This is a equivalent one body problem. This is force. Okay. Force on mu toward the center. Okay. And that is centripetal force and all. Okay. Fine. These are immaterial for me. Is that okay? m by 2, that mu equal to m by 2, those are all immaterial because that is getting cancelled. I'll show that one. Okay, now I will keep these things. Okay, this is for when they were doing circular orbit motion. Okay, now what is saying, at time t equal to 0, motion is stopped. They stop orbiting. Okay, fine, and they will start what you call moving with each other, moving towards each other because of the gravitational attraction. Okay, the motion is stopped and stars are allowed to fall towards each other after what time t, expressed in terms of time period of that old circular orbit motion. Okay, fine, at what, after what time t, expressed in terms of tau, do they collide. Okay, and he has given this integral, that integral must be used, otherwise they won't give the integral. Am I right? He said integral may be useful. Why would they give this much big integral if it is not useful? Am I right? Like typing is quite lengthy. Okay, fine. So this is the circular orbit part. I may need to use it. Okay, I'll just keep it. Okay, I will come back when I need that one. Okay, fine. Now they are going to stop. Okay, fine. Now if they stop, I mean, actually you have m here, m here. Okay, m here. Is that okay? So two equal masses. Okay, at r naught, this is suppose center of mass, they were orbiting, okay, on a circular orbit. Okay, now they stopped. Okay, and they started moving with each other. Okay, so equivalently, what is here? Equivalently, in this equivalent 1D problem, fine, in this equivalent 1D problem, is that okay? This is my O prime. Okay, this is my mu. Fine, this is my r naught. This mu stopped its some motion, radial, I mean some angular motion and all. It started falling into center of the force. These two are falling towards each other. That is equivalent to here, this mu falling into this center of the force. Okay, can I say like this? Okay, so that is the idea that I will keep in mind. Okay, I mean I don't have to draw this one, but I should keep that one in mind. Okay, now look at, because I mean I can apply everything for only one body here. Am I right? In this problem here, I need to think whether I can apply only for one body or both body. Okay, that I need to keep on thinking actually. Okay, in equivalent one body, now I have to apply force, I mean Newton's second law only for mu. I can get the problem done. Okay, now look at here again. Force is equal to Newton's second law. Force is equal to, this is better, m into dv by dt, because we need to find velocity first. After that, we need to find the time. Let me show that one. Okay, you check any other way. Okay, again, while writing this one, I should write mu again. Mu again. So now, what is that v actually? V is nothing but, okay, magnitude of v into minus r cap. It is moving, it is falling into this one. Am I right? Minus r cap. What is f actually? Minus k by r square r cap. That's equal to mu into d v by dt. Okay, into minus r cap. That negative sign got cancelled. Okay, I will get dv by dt. That's equal to k by mu. K by mu 1 by r square. Can you check this out? dv by dt, k by mu 1 by r square, negative sign got cancelled. R cap minus r cap minus r cap, you can cancel it out. Okay, now you should be what you should do is you should carefully write like this: dv by dt, dv by, now look at here, it is not function of time now. Am I right? Then you have to do it like this. I think I have done this one somewhere in differential equation. dv by dr into now these are quite important, because otherwise if you miss any sign here, you will end up with trouble. And you can guess actually, r is the radial distance. Am I right? This cannot be negative. Okay, speed is increasing. Okay, dv by dt must be positive. At least after landing on differential equation, you think over it. Just like our capacitor charging problem. Okay, charging or discharging problem. Okay, once you write that equation, keep that in mind. V is increasing function of time. It must be positive. Suppose if you made any mistake here in sign and all, at least here you should be able to correct it. Is that okay? Fine. So then what I do is, okay, since it's a function of r, I need to convert this one in terms of derivative with respect to r. I will use chain rule. dv by dr by dt, that is dv by dt. Okay, that's equal to k by mu into 1 by r square. Okay, that may be easy way. Okay, check that out. Okay, think over it. But I'm doing in ideal way. Okay, dr by dt. Okay, fine. Now you be careful. R is decreasing function of time. V is the speed actually. V must be equal to minus dr by dt. Can I write like this? R is decreasing function of time. V speed, whatever I took, that I took magnitude. Am I right? The direction was taken care here in the r cap. Okay, this is a magnitude. That's why V must be minus dr by dt. Okay, when I substitute that one, this will be dv by dr. Okay, this one is minus V. Fine, not V, because R is a decreasing function of time. Okay, minus V, that's equal to k by mu 1 by r square. Okay, now you can separate the variable. Okay, I will take negative sign right hand side. V dv, that's equal to minus k by mu 1 by r square dr here. Fine. Now you be careful. I mean, right now, I mean, you can't quickly guess what I'm doing actually. I need to find V as a function of r. Then that V equal to dr by dt. There time comes actually. Am I right? I mean, this V, I need V as a function of r actually. Then that I can write as dx by dt. Sorry, dr by dt or minus dr by dt. Okay. There I have time actually. Is that okay? Fine. Dt is equal to minus 1 by V dr. Okay. Now I can integrate this one with respect to time. I can integrate this one with respect to r, that I know. From r naught to 0. Am I right? Once they collide, r naught will become 0. Okay, that I know. Okay, this is the logic. Okay, why I'm getting into V of r? Because I can do this one at the end actually. And there comes whatever integral he mentioned. Is that okay? Fine. See this one. Because it's an accelerated motion. Okay, we'll see this one. Now, what is this one? This is nothing but, I mean, I'll say initial speed is 0. Am I right? That's what he said. Okay, 0. Initial distance is r naught. Can I say like this? R naught. Okay, fine. That R naught is the radius of our circular orbit. Okay, fine. Final one V of R at R. At R. Okay. Now let me integrate this one. This will be half V square. Okay, that will be equal to, fine, V square by 2, upper limit minus lower limit. Okay. So minus K by mu. What is this one? This is minus 1 by R. Minus 1 by r, okay, running from r naught to r here, okay, this equal to k by mu upper limit. What is upper limit? 1 by r minus 1 by r naught, okay, upper limit minus lower limit. Minus sign I have taken outside, okay, minus minus plus here. Now this r is smaller than r naught, am I right? Because r is decreasing now, okay, fine. Now you got the right, because every time I'll check whether I'm doing right or not. I mean, if I get reverse here, then I would get negative sign. How half V square can be negative? Now this R is smaller, this R naught is larger. Okay, initially it was at R naught, it is falling, so that's why that final R. Okay, so that will now I got V as a function of R. What is this one? That's equal to 2k by mu. Fine, 2k by mu. If I take LCM, okay, R naught R, okay, R naught minus R. So check this out. R naught minus R. Okay, fine. Now this one is again, what is that? This is again, can I write here only? Wait a second. This is again d minus dr by dt. V, that is minus dr by dt, because R is decreasing function. V, this whole thing is positive actually. Okay, you should have the negative sign. Okay, since decreasing function of time, derivative throw you one more negative sign. Okay, one more negative sign you should place actually. Okay, fine. Okay, something is missing. What is it? Under root is missing. V square, it was V square, am I right? Under root is missing. Okay, wait a second. Fine, is that right? Under root. Be careful. So dr, that's equal to sorry, dt is equal to dt is equal to minus root of mu by 2k, root of r naught r divided by r naught minus r into dr. Can you check this out? Am I right? This goes here. Okay. This also goes here. Dt comes here. Okay. Now this is ready to find whatever time we were looking for. What is this one? 0 at t equal to 0. They stopped from their circular orbit. That was r naught. Okay. Fine. 0 to t, that t naught. I'll say some yeah, some t or something. Okay. That is the time that I'm looking for, t naught. Okay. R naught to 0. Am I right? They are colliding means r naught to 0. Okay. Because I don't apply any, I don't do indefinite integral, keeping integration constant, then applying the those what you call boundary or so initial condition. That's not required. Okay. While defining integral itself, you keep everything. Am I right? This itself contain initial condition. At t equal to 0, r equal to r naught. That r naught is our circular orbit radius. Okay. Because it stopped from their circular orbiting. Okay. Now look at here. Now here you need to do the substitution. Now can you see whatever the integral he gave, it contains x square dx, root of alpha minus x square. Okay, that means what would you get? You have to put r is equal to some x square, isn't it? You just substitute r is equal to x square. Okay, dr is equal to 2x into dx. Fine. Then if r tends to r naught, okay, x tends to root of r naught. Okay. If r tends to 0, x tends to 0. Fine. Is that okay? Now what I do is I will absorb this negative sign and I will reverse the integral limit. Okay. Fine. That's better. This will be the time that we are looking for. Fine. That's equal to, I will absorb this, I'll write one more time, 0 to r naught. I'll absorb this negative sign and flip the integral limit. Okay. Fine. Root of mu by 2k. Okay. And root of r naught also I can take outside. Am I right? Root of r naught also I can take outside. Here. So root of r by r naught minus r dr. Okay. Now you do the substitution. Okay. I mean, after this one, I also don't know what to substitute, but I have seen his integral. Then I guessed. Okay. So that must be the substitution. Okay. Now you see this one. So that time is equal to root of mu by 2k. Okay. Root of r naught. Okay. What is this one? 0 to root r naught. Am I right? I'm going to convert it into x variable. Okay. Root of r is equal to x square divided by r naught minus x square. Okay. dr is 2x into dx. 2x into dx. You see this one. Root of mu by 2k root r naught. Okay. That 2, one more 2 will come. 0 to root r naught. X square under root, x will come outside. One more x is there. X square dx divided by root of r naught minus x square. That he gave actually. This integral he gave. Is that okay? That means they were expecting this step. They were not expecting you to know this integral. Is that okay? I mean, that's not a skill actually. Is that okay? That integral you can always look into. I mean, after maybe 1 or 2 years, you will forget that one. This integral, whatever you have practiced actually. But you should know the process actually. Okay, fine. That's equal to, okay. I'll keep as it is, root of mu by 2k root r naught into 2. What he gave? This is equal to minus x by 2 minus x by 2. Okay. root of alpha minus x square. In place of alpha, I have r naught minus x square. 0 to root r naught. Then what is the next one? Plus alpha by 2, that is plus r naught by 2. Okay. Sine inverse of x by root r naught, running from 0 to root r naught. Okay. Can you see this one? This is what he gave already. Now this is 0 in upper limit, and in the lower limit it is 0 because x is 0. In the upper limit it is 0 because root r naught the square, x square. This this is 0, r naught minus r naught. Okay. But this one again, at lower limit sine inverse of 0 is 0. In the upper limit sine inverse of 1. What is sine inverse of 1? Sine pi by 2 is 1. Sine inverse of 1 is pi by 2. Okay, that will be pi by 2. Okay. So that's why root of mu by 2k root r naught into 2, okay, into r naught by 2, upper limit only, into pi by 2. Can I write directly? Now what? This is not what he mentioned. He mentioned in terms of time period of our old circular orbit. Now you have to write this r naught in terms of your old circular orbit time period. This r naught is that circular orbit r naught only. Is that okay? Now you come back here, you solve for r naught. In fact, actually, you need to solve for r naught raised to 3 by 2. Can you see here? 2 into pi by 4, 2 pi by 4, okay? Root of mu by 2k, r naught power 3 by 2 is there. Root r naught into r naught. R naught power 1 by 2, r naught power 1. Okay, r naught power 3 by 2 is there. Okay, fine. That I should avoid. Okay, fine. Now you come back to this one. I have to solve this one for r naught. Again, in the option, there is no v also. Is that okay? Then how do you find v? Again, using this equation, I have to write v in terms of r naught. I have to substitute here. I have to write tau in terms of purely r naught. How do you write v in terms of r naught? V is equal to root of k by mu 1 by root r naught. 1 by root r naught. Okay. That v I am going to substitute here. Okay. Root of k by mu 1 by root r naught. This is my v, that's equal to 2 pi r naught divided by tau. I directly got r naught over 3 by 2. Look at here. That's what we needed over there. Okay. Fine. That's why r naught power 3 by 2, that's equal to r naught power 3 by 2, that's equal to root of k by mu, okay, into tau, am I right? Into tau by 2 phi. Fine. R naught, root R naught, okay, R naught power 3 by 2, tau by 2 phi, root of k by mu. Okay, that I'm going to substitute here. That time that we are looking for, okay, so 2 into pi by 4 into, okay, root of mu by 2k. What is r naught power 3 by 2? Root of k by mu, tau by 2 phi. What happened? These things got cancelled. One of these two also, 2 phi got cancelled. 1 by 4, tau by 4 root 2, tau by 4 root 2, tau by 4 root 2. Option D. That's right. Is that okay?